So let's look at maybe 11, 12, and 13. So 9 raised to x plus 6 equals 81 raised to x minus 8. It is exponential. The variable is at the exponent level. And I see that both sides can be presented with the same base. Now, I don't like non-prime numbers, but it works this time. So you can keep 9 raised to x plus 6, and you will change 81 into, that's it. So the left-hand side is 9 raised to x plus 6, and the other side is, and I have to simplify it, 2x minus 16. Two numbers are equal, and they have the same base. What has to happen to the exponents? They have to equal each other. X plus 6 equals 2x minus 16. Now this is linear. I move 2x, I get negative x. I move 6, negative 22. So x equals 22. Bless you. Now the next one cannot be done this way, because the left-hand side and the right-hand side will not be able, we will not be able to present those with the same base. It's not going to work this time. So let's look at problem 10, which is e to 11x minus 5 minus 3 equals 28,498. So then what do we conclude here? First step. First step. Yes, I have to clean it up. And that is the first step, by adding 3 to both sides. E to 11x minus 5 equals 28. What is this? 105. Now I know that e and 28,501 will not be presented with the same base. So therefore, I have a different procedure, a different mechanism that allows us to solve this equation. What is that mechanism called? Exactly. I have to apply the inverse function to both sides. So I get 11x minus 5 equals natural log 28,501. Do not get too impressed by the right-hand number. It's just a number. This is linear. I have to add 5 and divide by 11. So then 11x equals 5 plus natural log 28,501, and x equals 5 plus natural log 28,501 over 11. And this is the exact. If you want to check, you can. Okay, ready? Any questions on this problem? Any questions on this problem? Is this okay? Everyone? Okay, next one is a log equation. Log base 2 of x plus 6 plus log base 2 of x plus 5 equals 1. Well, log equations, we have to be careful with these, because if you remember, the log function is not a friendly function, in the sense that the log function is not defined everywhere. So I have to worry about it. So you either make yourself a mental note to go back and check in the original problem, or you apply the method I prefer, yes, to write the common domain. So what is the domain of this function? X plus 6 must be greater than 0. Log cannot be applied to 0 or negative numbers. So this one to exist, x plus 5 must be very good. So from here, x greater than negative 6, and from here, x greater than negative 5. But what is the common domain? I want both to exist at the same time, not just one or the other. Correct. So the common domain is -5 to infinity. Therefore, now I'm ready to condense. So let's condense the left-hand side. How do I condense the left-hand side? Yes. X plus 6, x plus 5 equals 1. Very good. Log of a product is the sum of logs. Excellent. So now this is equivalent to an exponential equation. Now, which exponential equation is that? From the base, counterclockwise. 2 raised to the first power equals this. And I multiply it now. 2 raised to this power equals this number. This is the most important concept in this chapter, chapter 4. Changing a log equation to an exponential one and vice versa. So now this is quadratic. X squared plus 11x plus 28 equals 0. If it takes more than 10 seconds to factor, 15, or maybe 20 seconds to factor, forget it. Use the quadratic formula. Yes. Two options, x equals, x equals. The first one is, very good. The second one is, okay, now the next one, please choose. Anything that catches your eye, anything that you would like to go back to. Which one? I don't think so. Let's look at 19. The figure on the right shows the graphs of the cost and revenue functions for a company that manufactures and sells small radios. How many radios must be produced and sold for the company to break even? Meaning revenue equals costs. They don't have any profit. So we're given the cost function, 5,500 plus 27x, and the revenue function, 47x.
What number is this?
19.
You just said cost equal to
Exactly. Which means 5,500 plus 27x equals 47x. The cost must equal revenue for break even. Exactly. Very good. Okay, so let's continue. So, of course, this is linear. Subtract 27, so 5,500 equals 20x. So x equals 5,500 over 20. So x equals.
75.
So the question was asking us to determine the number of radios that must be produced and sold in order to break even. What if we're asked to find the cost or the revenue at that point? How will you determine that? Exactly. So the cost of 275 will definitely have to equal the revenue of 275 because that's what the break even means or is, right? Revenue equals cost. Very good. Let's see what else catches your eye. I know I'm down to 9 minutes, so please choose. Anything else you would like to see now?
Number 20.
Number 20. Very good. Perfect. Well done. In number 20, we have x plus y equals negative 11. And we have x minus 3 squared plus y plus 6 squared equals 34. Okay, what type of system is it? Because it is a system. It's a system of equations. Are they linear? This one is, but this one is not. So it's a system of two nonlinear equations, we say. One is linear, but the other one is not. Can I solve by elimination? Are these the same variables? No. So my only hope is substitution. It doesn't matter which one I substitute for because both of them have coefficient 1. Let's say x equals negative y minus 11. I will replace x in the second equation, in that one particular spot where x is, by what? Exactly, indeed. So I have a negative y minus 11 minus 3, everything squared, plus y plus 6, everything squared equals 34. Now, obviously, this is an equation in one variable. It's quadratic. I have to fully simplify it and get y. Once I get y, I'm done. I can go back and find x. So this is negative y minus 14, everything squared. Since everything is squared, all the terms coming out of this must be correct. And I will square this. When I square y plus 6, how many terms do I get? Very good. This is what we did on the first handout, almost 3.5 months ago. So the first term squared plus very good. So now, of course, I have to square this. So y squared, y, very good, plus
196.
Thank you, plus y squared plus 12y plus 2 equals 0. Obviously, I would have to combine like terms. 2y squared plus 40y plus 198 equals 0. Now, you know what I'm going to do next. I know you do. Of course, make it as simple as possible. Now I'm looking at 99, and 99, it is only 3 times 3 times 11. There is nothing else. 9 times 11. See if you can factor. If you say, no, I cannot, I don't really see how to factor this, then use the quadratic formula. It's fine too. So I want the product of 99 and the sum of 20. Can I get a sum of 20 from here? Yes, y plus 9, y plus 11. So then we have two options, y equals negative 9 and y equals negative 11. It's good, but it's not good enough because I haven't determined x. But I know that x equals negative y minus 11. So when y is negative 9, how much is x? Let's try. Negative 9 will be 9. 9 minus 11 is negative. Very good. Now let's check with negative 11. Negative, the opposite of negative 11 is 11. 11 minus 11 is, I have to go back and check. Which one would you like to go back and check? We have to go back and check both of them, of course. Would you like to check any? But remember, on the test, do not waste a point or points by not going back to check and make sure that they are correct. Okay, so please remember, always check. Back in the original problem. Okay, we still have time. Next problem. See which one catches your eye. What about number 9? Is that okay?
Yeah.
Okay, let's look at number 9. So we have log base 4 of the 7th root of a to the 6th, b minus 1 to the 3rd, everything divided by 16. Okay, obviously I have to address the 7th root first. What does the 7th root mean? It means a power. Which power? 1 over 7. So I put it in front. 1 over 7, log base 4 of a to the 6th, b minus 1 to the 3rd over 16. Allow 1 over 7 to wait for us. So log applied to a ratio. What does that equal to? I have 2 factors at the top. So log base 4 of a to the 6th and plus log base 4 of b minus 1 to the 3rd. And I have 1 factor in the denominator, and that will have what sign in front? Because it's coming from the denominator. Correct. Log base 4 of 16. Excellent. So now I have a power, which I know what's happening here with the power. If I have a to the 6th, the power comes in front as a factor, multiplies log. Same thing here. Now I would like to be able to determine this if possible. 4 raised to which power is 16? 2. So you can replace this by 2. 4 to the 2nd power is 16. So then 6 over 7 log base 4 of a plus 3 over 7 log base 4 of b minus 1 minus 2 over 7. Remember, we have to distribute now 1 over 7. So we bring 6 in front and we multiply by 1 over 7. We bring 3 in front and we multiply by 1 over 7. And this becomes 2 and we multiply by 1 over 7. We have to eliminate brackets.